Good evening, sir.
Good evening, everyone.
Good evening, sir.
Good evening.
Good evening, sir.
Okay, good evening, everyone. Just wait. Okay, first of all, tell me, is there anyone who is having any doubt from physics? Whatever we have studied in physics, is there anyone who is having any doubt?
No, sir.
No. Okay. So we'll continue with that. But before that, we have a few worksheets for our practice, which we can practice for today. This worksheet is from refraction of light. So I think we can practice this today. We'll continue with that electricity later on. Since we are already a lot of ahead, right? So is there
And
anyone in, yes?
don't we have chemistry now?
Do we have chemistry today?
Yes, sir.
Okay. Okay, so let's do chemistry only. Okay. So thank you for reminding me. I thought it's physics. Okay, let's continue with chemistry then. So in the last class, what was the topic that we had done? We were doing chemicals from common source, and in that we had done two important chemicals. What were the two important chemicals that we had done? Okay, Aryan says to revise chlor-alkali process. Okay, Aryan will do that. We are just about 2 to 3 chemicals are left. Okay, once we complete those chemicals, then your chapter will be over. So of course we will revise that.
Okay, sir.
Sir,
Yes.
good evening, sir. Sir, actually, I have my exam, sir, from this Friday, and my first exam is science. And like I was discussing with my friends, and then one of them asked one question. I had a doubt in this too, so can I ask?
Yeah, sure, sure. What's your doubt? Can you share your doubt somewhere?
Sir, can I send it in the chat box here?
Yeah, you can either send it in the chat box, or you can send even through the support section. Right? We have the support and feedback group over there. You can share. If it's a click, you can share over there, or it's a simple doubt you can share over here.
So this, sir.
So the chemicals from common salt. What are the chemicals from common salt? Okay, so
Sir, I sent it in the chat box.
okay, you have sent is calcium hydroxide, CaOH whole twice plus Cl2, giving you calcium oxychloride plus H2. We were just about to do this reaction. This reaction is actually manufacturing of bleaching powder. So this reaction, it is manufacturing of bleaching powder. So let's start with bleaching powder. I will be just discussing this now. So your bleaching powder, as the name suggests, it is used in laundry. It finds its application in laundry for cleaning purposes or for bleaching purposes. So bleaching powder, here calcium oxychloride, this is also called as bleaching powder. The name CaOCl2, this is bleaching powder. So bleaching powder is the common name. Bleaching powder, its common name. Bleaching powder is the common name and chemical name is calcium oxychloride. So this is your chemical name. Chemical name is calcium oxychloride. Right? And its chemical formula being calcium CaOCl2. Now, what are the uses of this bleaching powder? Of course, we have seen how can bleaching powder be manufactured. Bleaching powder can be manufactured by passing chlorine gas over slaked lime. So when chlorine gas is passed through calcium hydroxide or slaked lime, it forms bleaching powder. So bleaching powder finds out its applications by releasing an oxygen atom from it. Okay, so CaOCl2, it releases a nascent oxygen. Nascent means a newborn oxygen is released from it. Also, it releases chlorine gas. So, this calcium oxychloride, it provides oxygen, and this oxygen which is produced, it is called nascent oxygen. So, this nascent oxygen, it is used for this nascent oxygen, it is used in the oxidation process. So, during the bleaching. So that is why calcium oxychloride, it's called bleaching powder and it finds its applications in bleaching purposes. Another important use is it is also used as a disinfectant. Also used as disinfectant. Got it? Now, coming to the doubt that was given to us, the doubt is the reaction is same, calcium hydroxide plus Cl2 gives us CaOCl2 plus H2O. Okay, your doubt is that whether this reaction is a neutralization reaction or not. Okay,
Yes.
so what is the definition of a neutralization reaction?
So the reaction between an acid and a base to form a salt and hydrogen.
Okay, so is there a base?
Sir, is there a
Is there any base in this reaction?
CaOH2?
CaOH2. Okay. Is there any acid in the reaction?
Sir, but then Cl2, it's they're like, isn't it acidic in nature?
Cl2 is not acidic in nature.
Non-metals are usually acidic in nature, right, sir? So that's why.
No, no, no. It's not acidic in nature. So from the definition, the neutralization reaction is a reaction where where an acid reacts with a base to form salt and water. Right?
I don't know, but then, sir, also salt and water are being formed, so shouldn't it be neutralization reaction?
Chlorine is acidic or basic?
Chlorine is not acidic. See, acids are the substances which donate H plus ions.
Yes,
Right?
sir. Yes, sir.
So here chlorine is not donating an H plus ions. So therefore chlorine is not acidic in nature.
So
Got it?
then what it is, sir?
It's an element, just. It's not acidic in nature.
Sir, only non-metal
Okay, sir.
oxides are acidic in nature, right, sir?
Which
Not
one?
only
Which one?
non-metals oxides are acidic in nature, right, sir?
Non-metal oxides. Non-metal oxides. Yeah, the non-metal oxides they show acidic behavior. As all they show acidic behavior in water. When the non-metal oxides are added to water, then they form acidic characters. Got it? Just as per the Bronsted and Lowry concept of acids, how do they define acids as acid as a substance that donate H plus ion?
So then what is CaCO2? That is bleaching powder, sir.
Yeah, bleaching powder, it is a salt of calcium and chlorine. Calcium, oxygen, and chlorine. Okay, so basically she was doubtful that she is having you're having a base forming a salt and water. So can we call it as an, and since we have observed chlorine in HCl also. Okay, so the doubt was that can we call it as a neutralization reaction? The answer is no. But as per the neutralization reaction, the reaction of an acid with the base to produce salt and water. Here we don't have any acid. Acid is a substance that donate H plus ion. Ions in the solution. Got it? Any other doubt?
No, sir.
Okay. So we were doing about the uses of bleaching powder. So in the uses of bleaching powder, I have just given you a few ages. So one of the uses I told you that it is used in laundry for bleaching purposes. We have seen clothes being bleached. So bleaching of the clothes is done by bleaching powder. It is used in laundry for bleaching purposes. Then the second use of this is it is used as a disinfectant. Disinfectant. Got it? So these are some of the important uses of bleaching powder. So how is bleaching powder manufactured?
Sir, by that reaction, it is formed. Then
By the
Or by adding chlorine to
yeah, it is formed by passing chlorine gas through slaked lime. Okay, when chlorine gas is passed through slaked lime, it produces bleaching powder. Another use it can be, you can write it that it is used as an oxidizing agent. So how it can be used as an oxidizing agent? Because it produces a nascent oxygen. It produces a nascent oxygen, so that is why it can be used as an oxidizing agent in industries. Wherever in industries we require oxidizing agent, we can use bleaching powder. Then the next important chemical is POP or plaster of Paris. So you must have seen the uses of plaster of Paris. You must have seen POP designs in your ceilings. There are somewhere POP designs are made in ceiling statues and other things. They are cast in POPs. So it's plaster of Paris. So plaster of Paris, it is also called POP. Okay. POP means plaster of Paris. It has its formula as CaSO4 dot half H2O. Okay, in the support group, I saw that someone has sent a doubt for finding out the pH. Was there someone from your class? So you have calcium sulfate hemihydrate. The chemical name of this compound, plaster of Paris. This is the common name. And chemical name is calcium sulfate hemihydrate. And it is manufactured from gypsum, right? Hemi means half. So there is half the molecules of water of crystallization. It is manufactured from gypsum, which is CaSO4 dot 2H2O. It's CaSO4 dot 2H2O. So calcium sulfate, two molecules of water. Right? So this will result in, when heated at 373 Kelvin. So the temperature is very important. You must remember the temperature at which it is heated up. It is heated at 373 Kelvin to obtain CaSO4 dot half H2O, and 3 by 2 molecules of H2O, they evaporate. This is what your POP has been formed over. If you heat at a temperature greater than 373 Kelvin, so all the molecules of water of crystallization will evaporate. Okay, and there will be just CaSO4, which is calcium sulfate. So calcium sulfate hemihydrate, that is your POP or plaster of Paris. It has the property of setting into a hard solid once mixed with water. So if POP is mixed with water, it will settle into a hard mass. It will become a hard solid. So you can write it like POP on reaction with water, it settles into a hard mass. So because of this, POP is used at various places. It is used in, it finds its applications in medical industry to fix bones. Okay, it is used to fix the fractured bones. So that is one of the applications of POP. So to remember the temperature condition, you should remember like 373 Kelvin is your 100 degree centigrade. Okay, and 100 degree centigrade is the boiling point of water. So that is what we are doing here. We are boiling, we are evaporating the water from. Okay, so heat it at 373 Kelvin, you will get POP. If you heat it beyond that, if you just heat CaSO4 dot 2H2O, if you heat it at a temperature higher than 373 Kelvin, to go higher than 373, so then you will just get CaSO4, calcium sulfate, which is dead burnt plaster. This is of no use. Yeah. Whereas POP is of use. So if you take POP, which is calcium sulfate hemihydrate, so this calcium sulfate hemihydrate or CaSO4 dot half H2O on reaction with 3/2 molecules of water, it gives us CaSO4 dot 2H2O. But you will get your gypsum back now, which will be settled into a hard solid. This is the hard solid which we find. Now, uses of POP.
Sir, is this reaction an endothermic or exothermic one?
Its reaction is exothermic.
Okay, sir.
So, uses of POP.
So CaSO4.2H2O is gypsum.
Yeah, it is gypsum.
Okay.
CaSO4.2H2O, that is gypsum. So, POP is manufactured from gypsum. So, the first use, it is used to make ceiling designs. Then,
Sir, it is used to wrap around the broken bone, sir.
wrapper, what?
Sir, it is used to wrap around the broken bone.
So fractured bones are
Yes, ma'am.
cement.
Fractured
Yes,
bones.
sir.
Yeah, fractured bones. Okay. So,
Cement,
it
sir.
it is used in medical industry. For fixing fractured bones.
And then so it is also used for design.
It is used for designing, yes.
Like
It is used
in
for
buildings.
designing, making statues and all. Fixing fractured bones. Any other uses? Okay. Used for making toys, statues, etc. So toys, statues, etc. They are made up of POP. Got it? So what all chemicals we have studied in this chapter, you are most probable to get one of the questions from their uses. The questions are generally wrapped around the uses of these chemicals. So the chemicals which we have studied today is,
Sir, could you one show the previous page? I'm writing.
okay, yes.
Sir.
The different chemicals which we have studied washing soda, chemical formula of washing soda being Na2CO3.10H. Washing soda Na2CO3.10H2O. Can anyone tell the chemical name of this compound?
Sir, sodium decahydrate.
Yeah, it is sodium carbonate decahydrate. And how it is manufactured? Yes, how do we manufacture?
By adding 10 molecules of
So if you add water to sodium carbonate, will you get washing soda? We obtain it by the crystallization of sodium carbonate. So if you perform crystallization of sodium carbonate, you get washing soda Na2CO3 dot 10H2O. Then what are the different uses of washing soda? Yes, please recall. Kashmi, what are the uses of washing soda?
Sir, it is used in making borax and it is used in soap industries, paper industries, glass industry.
Okay, soap and paper industry.
It is used to remove permanent hardness of water.
Okay, it is used in soap and paper industry. Used to remove permanent hardness of water. Permanent hardness of water. And used to make borax. Any other thing?
For cleaning purposes.
Cleaning purposes. Okay, it is used for cleaning purposes. Used for cleaning purposes. Purposes. Any other thing?
Used in like labs and everything for tests.
Okay. Some of the uses of washing soda. I think everyone had done very good about the washing soda. Everyone has understood about the washing soda. Then the next we had done
Sir,
baking
1
soda.
minute I'm writing, sir.
Okay, just remember I'm giving you. So I will discuss here now about baking soda and baking powder both. Okay, done.
Sir, 1 minute sir, writing last.
Okay. So the next one is, okay, I think baking soda. Baking soda is an important industrial chemical. Its formula being NaHCO3, chemical name sodium hydrogen carbonate. So first of all, you have to do the manufacturing of baking soda. Baking soda is manufactured by the use of ammonia, carbon dioxide, anything else?
water and salt,
Water and
NaCl, table salt.
NaCl, right? So we add these four and we get our product as, here we get NH4Cl, ammonium chloride is obtained. We get NaHCO3. Is this what we get? We obtain HCO3, sodium hydrogen carbonate, is obtained by this process. Now, baking soda is a important ingredient of baking powder. Now, what is baking powder then? Yes, what is baking powder? See, baking powder is the is the thing that we use for cakes and all. So that is your baking powder. Your baking powder, it uses baking soda plus mild acid. Baking soda plus any mild acid. Mild acid means you don't have to use any strong acid. As we know that baking soda is slightly basic in nature. So if you add baking soda, it will spoil the taste of your cake. However, it will make the cake spongy, but it will also spoil the cake. It will spoil the taste of the cake by making it a little bit bitter. Okay, so we add a mild acid to it so that the taste of it can be prevented. So that the taste of it can still remain the same. Okay, so any mild acid like tartaric acid can be used. So tartaric acid, a mixture of tartaric acid and baking soda is used as a baking powder. So don't consider baking soda to be baking powder. Baking soda is an ingredient of baking powder. Okay. And if you see the applications of baking soda, so for the applications of baking soda, we observe. Yes, Siddharth, what happened?
I think so.
So for the uses of baking soda, we have seen it is used in cake industry for making the as an ingredient of baking powder. It is used in soda acid fire extinguishers. Okay, any other uses?
Sir, as an antacid.
Yes.
Sir, it is used as an antacid.
Yeah, it is used as an antacid. So baking soda, it is used as an antacid. It is used as an ingredient of baking powder, also some other purposes, right? So these were the two important chemicals. Okay, what will happen if you heat if you heat washing soda? Another question here. What will happen if you heat washing soda? Anyone? Aryan? Aryan?
It will become a nitrates.
What will happen?
Sir, it will turn into sodium carbonate and
Yeah, it
And
will
lose
lose
water.
the if you heat washing soda, it will lose the water of crystallization, and what is left with it is called as soda ash. So it'll just be left with soda ash, which is also called as sodium carbonate, and that will be of no use. So baking soda, then we have done today. We have done chemicals, POP, and bleaching powder. So these are the four chemicals that you have to do: POP, bleaching powder, and you have washing soda and baking soda. There is a difference between washing soda and washing powder. So washing soda and baking powder. These are the four chemicals. Is there any doubt? For all these chemicals, you have to remember their common name, chemical name, formula, their two uses, right? At least 2 to 3 uses you should be able to remember for all of them. Right? So today we complete this chapter. We will discuss the question answer of this chapter in the next class. Okay, anyone having any doubt?
No, sir.
Okay. Okay, so bye all of you. See you again in next class. with
Bye,
question
sir.
answers of this.
Bye,
Okay,
sir.
bye.
Bye, sir.
Okay, sir. Thank you, sir.